We are in live now, sir. So, very good morning to all the
Yeah,
participants. And it is a great pleasure to have you all here for Knowledge 4.0 webinar series, which is one of the unique initiative of Chennai Institute of Technology under the guidance of our Honorable Chairman Shri P. Sriram, a successful first generation entrepreneur, a well known industrialist, and managing director of NK Group of Companies. And Chennai Institute of Technology always keeps the door of learning open even during this pandemic situation by conducting Knowledge 4.0 webinar series, under which we are conducting so many technical webinar series, career guidance webinar series, research webinar series, alumni webinar series, and so many workshops, seminars, short-term training programs, faculty development programs, and conferences where eminent speakers from academic institutions and industry experts deliver recent advancement and technologies in engineering domains. And today we have a technical webinar series titled Aerospace at the Leading Edge Nurture Technology, which is going to be handled by Dr. Jayakumar Venkatesan, CEO, Cygnus Aerospace, United Kingdom. And Chennai Institute of Technology was established in the year 2010 by our Honorable Chairman Sri P. Sriram, and now our institute is being ranked within top 10 institutes among private engineering colleges in Tamil Nadu. And it is our great pleasure to welcome our guest speaker today for this session. And I request Ms. Yes Harini of First Year Triple E to introduce our guest speaker. Over to you, Harini.
Good morning to everyone. This is Harini S. pursuing first year Triple from the Chennai Institute of Technology. Today, as we all know, the webinar topic is webinar on aerospace at the leading edge, a nurture technology, and is going to be presented by Dr. Jayakumar Venkatesan, CEO, Cygnus Aerospace Limited, UK. Dr. Jayakumar Venkatesan is a Chief Technology Officer for the Synergy Moon. He is one of the finalists of $30 million Google Lunar X Prize. He is an astropreneur and Chief Executive Officer for Valles Marineris International Private Limited, India, and has special interest in human space flight program and orbital research station. He is also a national point of contact India for Republican Unitary Enterprise Scientific and Protection Center of Multifunctional Unmanned System of the National Academy of Sciences of Belarus. Dr. Jayakumar Venkatesan is expertise in spacecraft engineering and additive manufacturing technologies suitable on the moon and Mars. Additionally, he is also a nanosatellite researcher and chief technology officer for KSF Space Foundation, United Kingdom. He is a national point of contact India of the Space Generation Advisory Council in support of the United Nations Program on Space Applications, Austria. He is a visionary board member to the Technology Contact Upgrade organized by Russian venture company Skolkova Foundation, an agency of strategic initiatives, Russia, and vice president of international affairs for the International Academy of Space Law, Moscow. He is an advisor to the Global Center of Compliance, Hazard, and Disaster Management. He is also an aerospace education consultant for national research universities in Russia, like Moscow Aviation Institute, and he is also a mentor for Vayu Sutra Aerospace, IIT Madras incubated company, president of technology of Canadian Graphene, Canada, and founder of Cygnus Aerospace Limited, United Kingdom. We CITNs are immensely pleasure to have you here, sir.
yeah, thanks a lot. And thanks for introducing me. A very brief introduction. This looked like a big presentation to me. Like, okay, so how many minutes I have to start? It's like 40
Yes, sir.
minutes.
Yes, sir. 45 minutes, sir.
Okay, cool.
Yes.
Yeah, thanks and thanks for joining and thanks for invitation for Chennai Institute of Technology. And
Sure,
it's
sir.
a great pleasure to interacting with you in India, and I'm spending some bit time in India to exploring the research activities and market scenario in India. And I just want to give a glimpse about what is the aerospace technologies and what is the futuristic technologies that will give the job opportunities and also that will create the next generation technologies to what it is like that. So I'm taking right now into the global scenario. Like for example, in a growth, I just especially in the growth in India, I want to emphasize here. It is like a low cost carrier actually. If you talk about an Asia Pacific market, it's like a low cost carriers, and also the people looking for, very cheap airline tickets, and also very affordable connectivities like Geo and all something like. That's the demand actually, but we have the volume is very big here. That is the market size of India. And in the future, in especially in the aviation sector, it's like more than 2,300 aircrafts that may be coming in the next 2 decades. It have the market of like Airbus and Boeing, or maybe the private aircraft manufacturers. They might be having the opportunity like 320 billion market in India. So mostly it is like they are like people are operating by the Indigo and all like. The seating capacity is little bit less, and it's like between 90 to 200 something like. So the emerging market is here mostly in the space exploration. Like the Gagayaan is the biggest topic here right now, and everybody is looking for that after the Chandrayaan actually, the crash landing on the moon surface, and. I happen to be worked as like a chief technology officer, and still we are working on a private moon landing mission. That's Google announced 40 million who's landing on the moon, but we reached to the finalist. Ultimately, we cannot able to secure the launch because of the launch vehicle not availability and also the funding issues. So these are all the bottlenecks and also the challenges are in the space industry. And I would like to tell about something, some realistic way actually, like what are the trends are happening around and something like. In Chandrayaan 2 is like that was the recent country. There's one of the big giant leap, and Chandrayaan 3 is going on, and the Gagayaan is on the way, like something they are doing on the manned space program. And we also submitted the proposals to work on this mission, and we are waiting for the green signal from ISRO. So it is like the defense budget, and also in the another side in aerospace, it means also defense and space actually, and aviation. In defense also they have spending nearly it's like 44.6 billion. I mean like for 2019 to 2020 something like that. It's like next 5 years. I mean like India is heavily is modernizing the aircrafts and the satellites, and even our GSLV is coming up man-rated vehicles. Once if we succeed in the Gaganyaan mission, then it will be like a transform like a SpaceX. So this will be the strength and the strength of India right now of ISRO's capabilities. Right now they are doing, and we. So I just okay.
Shall we
Second one.
share the screen, sir?
Yes, yes, yes. Oh,
Okay.
sorry. Yeah. So
Ah,
now
yes.
I can. Yeah. Thanks. So I think the brief introduction was done, and now we go about what's happening in a space industry. Like how we just what our main job is like to work on the space technologies that is easy to access to the space, like building a small satellite, and we can give the opportunity to the people to whoever want to build the small satellites. We can help them to build the satellites and fly to the space something. And also we offer the training program for students and young professionals to operate this. So is spacecraft simulators that they can train like astronaut, and they can fly to the space something like. So every kid's dream is the flying to the space, and or you can experience something like to operate some flights something like that. So our main activities are like we do the launch consulting services, and also we do the AIT services, and we do the data analytics platforms, and also small, like space systems development, like lunar rovers or something like that. And what's new in 2020? Like everybody, we understand that we are in the COVID situation, and but does not affect majorly in mostly in the research and development activities. And mostly who is working on IT background, they will work remotely. Only the manufacturing production has been stopped, and something is going on. So the in the technology development and innovations, mostly continually is the shaping the aerospace and defense industry. Some of them are significant development is like modernizations, or everybody is going on electric bike and electric car, something like we and also in future there are many lot more researches are happening in electric propulsion aircrafts. That is like future aerospace manufacturers, they are trying to build a more fuel efficient aircrafts, like next few decades. There will be like a rapid growth in like air travel demand. It's like how many shuttles of the flights are happening around, thousands of thousands flights moving around in a single country. So the demand is like we have increasing the demand, and also in the same time the climate change is like carbon emissions, something that is the creating the major pollution in the high skies. And I think it's something near to the stratosphere. So which is technology evolving. It's like the several companies are they are, I mean, including the Boeing, and there are several companies came forward to work on electric propulsion systems like electric aircrafts and like that. And also there some in future the autonomous flight, I mean, aircrafts also will trying to come, like how the Tesla has made the driverless cars, something like that. That driverless cars have been achieved in Russia, and been have been like in a school cover the campus. In our campus, so we have the driverless car, and you can travel within the campus. It's like the campus itself, some around 20-kilometer campus. So you can use the electric car and you can move, and it is like autonomous. There is no driver or somebody there, something. And mostly the urban mobility, if you think on, it is like unmanned aerial vehicles, and also there are many things are advanced as are coming, like autonomous flying aircrafts and autonomic weapons deploying for the defense activities. There are so many, I mean, the growth are happening, and also the automated flight decks and information systems. So these are all the technological systems that is compounding. Mostly the high productions are, I mean, it means we how you can able to achieve this target, like 2,300 aircrafts. I said, like we will project in next few years. So then how we can achieve this goal? Thus, we need a higher production, and also smart manufacturing systems on the defense equipments, and digital technologies that can help them. So these are all the industrial, some of the trends that is happening around. Uh, you can see the what is the industry trends right now. Industry trends are like the small satellite. Especially we are why I have chosen this space as a topic. So we are the working on the space industry more. I mean, a lot of work we do in satellites and in the spacecraft systems. So that's why we have chosen the topic of industrial trends and 8 key points takeaway. Just I would like to share the some glimpse about these activities. The smart devices are coming in every home. We must in the future, maybe in the next 2 years, you can at least 10 devices in your home actually, like a smart watch, or maybe your electric scooter, or maybe smart TV, smart air conditioners, and the smart energy meters, even automated kitchens. There are so many things. So for that you need bandwidth and also the internet. For that, what you need is you need to build the satellite, and you need a 5G and also M2M communication systems. And these are all the technologies that you needed. And also how we can able to achieve is you need to build for that we need a satellite to achieve that. And also we need Uber guys, like somebody we need to drop you at 400 or 450 kilometers, or maybe wherever you want to go in a space. So we need a Uber guys like ISRO and Roscosmos or NASA or SpaceX or anybody like Arianespace or JAXA, some companies. And after that, we need a disruptive ground service station services, because wherever you are in a terrain or village, or wherever the remote location, urban location doesn't matter, but you should have the compromising bandwidth, and also you need to do that. And next is like electric satellite propulsion, because everybody consider about the climate change is a very critical issues, and United Nations is also keep always insisting like to follow the should not pollute the environment, and also even a space actually. Even a space is too much of polluted of million devices. I mean the inactive satellites have been flying around the at lower Earth orbit. So that is the very it is create the very damage to the active satellites. Then the satellite is cost in the some several terms of the millions of money, and it can easily the debris can hit and damage this thing. So that's why the European Space Agency have been started the idea of offering 1 billion pounds to like to create the disruptive technology to remove the space debris. So there are the several consortium companies are started working, and we also proposed along with the research proposal to how to clean like Swachh Bharat in space like that, in another way like. So next is like integrated IoT and architectures for the satellites, because the Internet of Things is going as like intelligence of things actually. It is not about internet. It goes to with the intelligence. And next is like a low cost downstream and imagery solutions. This is like I think most of them you use how to use the Windy app. I mean, in app you can use the app and find out what is the weather today, and where is the raining, and where the cyclone is going at what speed and which direction, something like. You itself become a weatherman, something like. And next is like affordable connectivity and the solutions. Affordable connectivity and the solutions, it means you can able to afford actually. What is the price in India, like 200 rupees to paying in a month? It's like a Geo is okay, that's fine. You can get 1 GB or 2 GB in a day, so that sounds good. And it's not like previously it's like 500 rupees or something, like you paid for Airtel or some companies like Vodafone or something. And after the Geo came and something like, they had made the affordable global connectivity solutions, and that created many users and the many bandwidth. And later, it's like a human transportation legacy, like Elon Musk or Jeff Bezos or somebody, they exploring the Mars, something. So here the small satellite launch and demand and supply. How the increasing the demand of small satellites of launch vehicle is mostly some of them are dedicated launch, some of them are like a ride share. It's like a Uber pool. Somebody will go like in a Uber, you can hire your complete car to do go somewhere, or something like you can hire the Uber and go as a pool. So like this, the dedicated launch is like the single satellite. It is like the complete capacity will be fold. I mean, like for the launch company. I mean the launch vehicle. So there is no room for there is no extra room to allow you something to put your luggage or something like that. It is like fully dedicated launch. That is called a dedicated launch. The 104 satellite, it's kind of the small satellites are assembled. I mean, like they have put into the PSLV 4 stage, and they integrated like with the CubeSat deployers of 104 satellites. This is how India has been created the history of 104 satellites deploying to the space. So something there will be like some of the scenarios are, you can see the some of the forecast about the small satellite launch and supply of the global demand. And as I mentioned, next in 10 years, you can able to 11,640 satellites is likely to be roam around. I mean the near to our space. So it means I mean everyone is going to use smart gadgets, mobile phones, and we have the huge demand on it. So the people who are working on small satellites and also in the launch vehicles, there will be next billionaires like the SpaceX and or Blue Origin, something like that. And the next is like, what is the future of the space industry manufacturing? Okay, so the industry trends are many people are talking about Industry 4.0, and there will be like there are many names have been created, but what we are working on in the future of the space industry, like the like it's like we're introducing the smart manufacturing that can optimize the work, and also low cost, and also the mass production. We want to achieve the zero rejection, and also there is no material waste, something like that. The conventional methods, you can see there should be only one satellite at one time in the space industry. And this will like single mission objective is, for example, like I'm going to the moon. That's only the objective, or else I try to demonstrate only one communication. Just I want to send push and forward messages from the low Earth orbit, like a hello message, or maybe you can find the weather at the low Earth orbit, something like that. That's a single goal. And you need to design the mission design and subsystems and the realization, and after that they will start procuring the sensor. These are all the conventional methods actually. And then assembly will go to the assembly section, and it will take too much of lead time. And after the integration and testing, and then they say after the certifications, they said ready to go, something like. But the future space industry is like a combination, and everything is like like they have reduced the highly, I mean, like a very fast, you can quickly, you can able to generate, you can produce your satellites. There will be like the system standards and everything come, and the qualities and everything that will be inspected at on the spot, and the system miniaturization, and also mostly the industrial internet of things, and the serial productions, and mostly the collaborative robotics. Robotics placed in a critical role, and AI can is implemented in robotic assembly lines, mostly in the US and UK and even Russia. So the robotic assisted assembly lines are happening right now, mostly in the car manufacturing industries, and it will create the reducing the lead time, and also the low cost, because they have cut short the employees also. So that is the reason. And also in the same time, there will be like additive manufacturing. There's like no zero, there is, they don't want to waste the no materials, because this is a titaniums alloys and aluminum alloys. These are all very highly costly materials, and also we try to use the different suitable materials for futuristic materials. That research also is going on. And mostly the people want the system integration and the smart manufacturing. So this is like, it is like the one side is the quality is improving, and another side is like a zero defect, and you can get deliver the something on a right at a time. So this is like uberization of the ground stations. So mostly the uberization of the business models, something like, we need an existing ground station business. There are people are, many of them in the villages, they might be kind of collect some rent for installing the base station, something like that. So it means, like they wanted to go global connectivity, and the private ground stations are coming now, and the private, I mean, ISRO also trying to support the private initiatives in India. So then, the communications, I mean, telecommunications also will come in a private. So there will be like a single service provider. There will be single ownership. I mean, we can compare to the competitive approach and collaborative approach and disruptive approach. These three are the futuristic things in the satellite communications. So what happened? This is the single service provider, and the single service provider of the, I mean, like there will be users, something like they own the station, and they will upload the data and send it. So this is the satellite, how it will work. It's like there will be like a single owner. He will upload the details to the satellite, and it will broadcast to the people. I mean, it will start conveying the information to all of the people, to the end users. Like you are watching the television, you are watching the mobile or something. You are using the mobiles, telephone making, video call making, and there are the different communication device, and also the military communication satellite radios. That is the different methods they use, and they use the different frequencies. And the collaborative approach is like there will be like the several ground station. It is not like a single owner. And in Dubai and all, like you can see, there will be the ground station will be owned by this is only the one of the one or two only two companies in Dubai and UAE. But some of the countries like in India, or I mean Russia and UK, this place we have the a collaborative approach. It is like ground stations. I mean, like there will be several ground stations, and there will be like I mean, multiple users. Like for example, Geo, Airtel, Vodafone. There are so many things, and this one method. And next is like a disruptive approach. I mean, hereafter, for example, like many startup companies are there. I mean, like for example, Samsung may, there is a possibility like Samsung itself, they will launch their own satellite constellation. Maybe Geo itself, they can launch their own satellite constellation. Even BSNL also itself, the 5G satellite constellation. That will be, and also they can give the tender to the private, or maybe the private companies like some companies like SpaceX, like similar, like the companies are OneWeb, the Planet, something like. So they can launch the disruptive, the private ground station, and they can provide the service like private privatization in the space industry. Like next is all electric satellite. This is the disruption in enabling the migrations, because people are, they don't want to use the traditional electric propulsion systems. It is by 2025 they are trying to geostationary orbit players, something like the communication people, GPS people, or they are trying to use the satellites in the future. Is like at least one space asset will be in the form of the electric platform. It is like there is no chemical propulsion systems that in the future they are trying to use, and try to avoid these chemical usage. And also they consider they wanted to go as like a green propellant. And also if you go as like a green propulsion, like in a space industry also, they will give the some subsidiary and some support, like I mean they can reduce your 20% or 10% of the cost of the satellite, something like. So this is the most important thing. And this is like the industry partnership. Mostly the electric propulsion specialists in the business, this will be the propulsion systems are the suppliers, are like engine suppliers, like to the automotive industries. So it will be giving us like this give create a huge demand, and many satellite operators will buy. And the strategic decision making is like operator willing to diversify the missions and go everything into the conventional platform to. It is like you are using the IC engine and you are converting to the electric engine. So it is like a similar way in automotive industry. It is like in space industry also. And this so technology transfers is the integrated propulsion technologies, that is having the standard platform, and there will be like a key technological benchmark that must be do. And also the radiation hardening, that is most important for every satellite components that needed. And next is like investment decision, the platform reliability. Once you have the flight heritage, you can able to gain the investors confident, and you can do a lot of business development activities. And business development in the sense of manufacturers, like migrating towards the operators, and mostly the standardized platforms that leading the way of the platform. That's why this generation we have started in the CubeSat platforms. Yesterday also I given a lectures on the CubeSat satellites, because this CubeSat is like a standard platform that you can plug and send your scientific experiments or whatever your communication device to the space. It is like just everything will side, but you have to, only what we do is you just plug your scientific instruments and you can fly to the space. So this is how it comes. And the commercialization is mostly the um, biggest requirement. And also there are a lot of diversified schemes are there. uh, they're working. And this is the internet of things. Internet of Things is like mostly the expanding the terrestrial infrastructure, and also mostly like in Andaman Nicobar, and still in Andaman Nicobar and all, only they are experiencing the 3G itself. It is very difficult for them. So this IoT satellite constellation and the 5G satellite constellation, once it comes, so the terrestrial connectivity, also it will be fulfilled. And mostly the connectivity by the satellites, that can be the expansion of the things. Mostly, the driverless cars are mostly they are trying to get the direct satellite link, mm, uh, direct satellite link, because the internet. If you feel the internet is down, then you will be in the trouble. Something, so that will cause some damage or something like. So what will happen? In this situation, mostly the satellite direct satellite connectivity for the driverless cars and the driverless trains and something like that. That was the planning. The planning is happening something. So maybe in achieved the next 2 years. And the machine to machine ultra dense deployments of smart factories. And you can think that when sensors and systems, it is like without direct terrestrial link, then it will be the satellite based narrow and broadband services. Mostly we'll integrate with the IoT architecture with the smart factories and also the logistic assets tracking. That is the most important for every manufacturers, and especially for precision metals producers, and also military and space components producers. And mostly the minimum, as I said, with this year itself, I mean, like 2020 itself, the 10 connected devices, and you can expect the 5 billion internet users. You can imagine, like, you have only one tap of 10 centimeter dia, and you can experience. You need to collect the water for some. I mean, like multiple users. It's like, for example, 1 million. It means it will be very less. Maximum your output is like 100 mbps. So 100 mbps it is used by millions of users. So how we can able to offer the I mean affordable and also very reliable internet. So we need more satellites in the future. So that's the thing. Next is like a low cost earth imaging solutions. That is this is the app, like as I mentioned, like windy app. So you need to open the app and you can find out the what is happening around in your region, or maybe you can look at in UK what's happening and what's happening in India, or maybe you can look at what happening in Malaysia or something like. You can look at the using the just need not to see you itself become a weatherman, something like. And you just need to open the things and you find there will be like two things are there. One is like on demand data or real time data, something like these real time data are mostly it is necessary for driverless cars and the I mean like the assets moving and these things. But for some of the things are like offline data we needed for the analysis of the mineralogy or something like to understand the mineralogy mapping or something like that we can do with that. And for estimating about some how much granites there in the hill or something like, you can calculate by using the offline images, satellite images. And this one is the next generation earth observation market. This is like this is like a normal satellite, and with there will be like different stages. Here the artificial intelligence will plays a major role. It's like a next generation earth observation market. It's all mostly the purely with the space applications, mostly the driving integrated detection to tracking of architectures that involves the diverse sensor solution. So we have the multiple sensors that will be connected at one time, and we need the three stage of the confirmation whether it's happening or not. Something like the stage one is like satellite to the ground, and you process the surveillance data, and that will go to the on-site satellite confirmation, and then it go once on-site confirmation by the CCTV camera, and the future it is like. Next is like affordable global connectivity solutions, as I said. The small satellite operators, which is constellations of size from 50 satellites to 4,425 satellites, which enable us like a low cost connectivity across the industry by 2022. 25. So the thing is like if you are in urban locations, then there will be like a fiber optics. It's coming. Even Geo also offering the fiber optics, and this is the Geo based communication systems that Geo satellite will interact, and satellite plus terrestrial integrated service will be connected with that, and it will goes to the uninterrupted ATC for the aircraft's control, aircraft communications. And this like a low latency it is there, and also the low earth orbit based satellite constellation that will give the affordable connections, like in the remote locations, and also in terrestrial telemedicine services, and affordable internet services, and you can use the Wi-Fi on board in the aircraft, and something like. Some of them are driverless car, and driverless trains will be there in actually in Dubai and all. Like driverless cars, I mean trains are there. So like in future in India also it will come. So by the time this is like a global, I mean transit and traffic will be there, and navigation services and connectivity services like automated platform and uninterrupted connectivity. That is the biggest constraint. And next is like the maritime surveillance and automated information systems for solutions, AI solutions. Recently, India and France have been made a collaboration, and they have launched recently the satellite to track the vessels. I mean the ship vessels. This like human transportation and the legacy, the future. It's like International Space Station, Moon, and Mars, and also the space station, something like this will be the new gateway of multi-segment in the space. It's uh, like we are right now. We are on the Earth, and I mean, we have reached to the International Space Station and Moon, and the next is thinking about the technologies to the Mars, something like. So, space industry predictions. Normally, what is the space industry predictions are uh, something like what will be the next things. Uh, Something like I mean uh, the industry what is looking for actually this what kind of the technologies have been like succeeded so far, and hope you know about the SpaceX has been successfully they have demonstrated one thing, and about the recently the Space Dragon crew and this autonomous fly and dock to the International Space Station. This have been achieved by SpaceX by using the artificial intelligence, and also they have used the technologies they have replaced the traditional systems with the advanced systems like touch panels and those things. So next is something like there will be people are thinking about only the astronauts will go to the space, but now Blue Origin have been started the suborbital space tourism and finally arrive by this year, and the two astronauts fly to the suborbital space and they will come back. So this is the some of the two leading companies like Virgin Atlantic and there will be some Blue Origin. They are started doing on space tourism activities, and they have succeeded. And also the price is around $200,000 plus. I think the tickets they have pushed. And the next is the Mars missions have been take off this year itself. There will be like a four Mars missions have been like a planned by even the UAE also the first planetary mission in they have started and also the Japanese also sending the probe to the Mars, and so by early 2021 something like. And in Russia, the Ankara is one of the biggest heavyweight rocket. It's like there is like a 5 years of gap in that. In Russia's Ankara's rocket was scheduled to resume the flight operations in this 2020, and Russia has been launched the first so far. The Ankara mission was in like in December 2014, and now it is like they have started to work on by seeing the Elon Musk big size rocket. So I mean, Russia have been like wonderful big size of the rocket, and they started working on the Ankara rockets right now. And next is Federal Communication Commission in US. They have they are running the actions for satellite C-band spectrum instead of letting the satellite operators to handle it. But they are giving to the they are sending the actions so that they can build in the confidence, and also it goes to the C-band spectrum to use for the 5G cellular networks in future in US. So that's why in Intelsat and SES and Telesat and Etisalat, they are from UAE. They are trying to use the spectrum for the 5G. The people are competing in the 5G in thing. So mostly the national space launch programs like United Launch Alliance, SpaceX, Blue Origin, Northrop Grumman. There are so many players now, and also there is a lot of privatizations are coming on in this. And the next is like the satellite servicing and debris retrieval mission. As I mentioned, nearly European Space Agency they are they put the grant for nearly 1 billion pounds to work on the clean space mission. That's like to clean the space and clean the lower Earth orbit in orbit debris. So especially, the recently the OneWeb and Airtel Global also acquired 1 billion money. They have invested in OneWeb and also OneWeb the satellite constellation, and there are planning for the two mega constellation companies. That will be a rapid beginning of it is like mostly the initial proposal was around 650 satellites, and this may be increased with the 60 satellite in each of the SpaceX with the Starliner something like. So then it will goes up to the 1,000 satellites by next year. So the commercial imagery buyers are something like high resolution images, and there will be like technologies companies called the Maxwell Technologies and Digital Globe, Black Sky. There are the commercial players there coming to the contracts. When you go to the register office, you maybe have the property documents. In the future, you have the digitalized the property documents like in UK and Dubai and all. They have the digitalized document. You can see your property document, and you have the 3D view of everything like in the software itself. So something like the technologies have been going up in the next generation. And SpaceX has been like now after they gained 10 years, so they have become one of the popular right now, and they are the one of the succeeding very they are growing very fast, and twice the time of the space last year after this thing. So there will be like 24 Starlink missions have been like company has been going to grow. It's like a broadband constellation. It is like and also the China is another side of China is launching the rate of they have very states. They are saying they are demanding they plan to launch many satellites, but because this COVID situation and there will be like this pandemic situations, I mean China is fall down, and now there are the emerging market in India and also the Europe and the UK after the BRICS exit. They are growing up in, and also they have a lot of positive signs in launch vehicle technologies and the satellite technologies. And after that, the Telesat is like one of the constellation by the China. They have picked the partner to build around the 300 satellite mega constellation. That is the Thalisar in Alina space. From Italy, they have signed on the 3 billion contract in last year. And Airbus Defense and Space that will be also the planning to build a Telesat Leo. And I hope this will be in orbit in 2023. And the small launch vehicles that can be entered into the market, like there are many startup companies have started working and to working on the launch vehicles. So the Earth observation market, it's also going very critical. And the images, the satellite images are going in a very precision. Like you remember the Cartosat recently, and there are many satellite technologies have been like they upgrading, and it's like how your mobile phones are keep every year it is get upgraded. You can use 108 megapixel camera, I think, as of now today. Like I mean the cameras resolutions keep increasing, and also in the satellite cameras also this are also increasing pretty much. And also the compactness is coming, the many nanotechnological initiatives, and also single chipsets that will be used. Previously they have the very multiple systems, the very complex systems that will be integrated, that will consume a lot of time. But nowadays it will be like it's like a single chipset that can fly to the space, something like it's done. So mostly the European market is like they are advancing by using their technology as first in the place to implement and to experiment it. So this is how the mostly in the things are working. And the next is like the flexible communications, that is the supreme activities. It is like the investment is very high input, and technological barriers are very pretty much high. But recently they have tested the 5G in Netherlands that created the environmentalists. They have raised the issues about the birds issues. So the people are trying to standardize and how to come over like this. And next is like Artemis. Artemis is uh, Artemis is like they are going to the moon, and the US is creating the historical mission. That is, they are flying to the moon back, and they have going to spend like 1 billion on this financial year 2020, and they have awarded few companies to investigate and take part in this mission. And this will be the signals for the intelligence from the space takeoff. And there will be like many France-based companies and Luxembourg and India's PSLV. India also upgraded to the SSLV because in order to keep the demand and to supply. So that's the thing. And next is like a commercial crew test flights, like both SpaceX and Boeing. They are doing like Starliner. Boeing Starliner is crew test has happened, and the SpaceX crew was successfully demonstrated, and they have signed on a few contracts with them. But it's like this is like a completely like new disruptive technologies. But in Russia also the planning to send the next year the Orion space shuttle. Sorry, not Oril, not Orion, Oril space shuttle. So this is like also autonomous docking to the International Space Station. So I think there will be like a huge competition, and also there will be like many commercial alternatives, like how you use the Vodafone, Geo or Airtel in the space industry. Like there are like many technologies, and also the government also now can step into the invest in the private public partnerships. And in UK, they are work very positive, because after the BRICS exit, there are UK space agencies supporting the private startups and even the companies to grow and make something like to go to the global market. So this is how the initiatives are happening around. And the thing is like I just this how I just finished my small talk on the disruptive technologies in aerospace industries. And this is my contact information, so you can feel free to write to me by email. And I'm happy to answer your questions if you have. Or you can follow a Cygnus Aerospace YouTube channel. We usually conduct some space activities and programs and for the learners something. Yeah, thanks a lot. Thanks for listening.
Yes, sir. Thank you, sir. And can you see the chat window, sir, on the right side? Uh, the
Hold on.
third icon, chat.
Okay. Yes.
Yes, sir. So there we have a few questions, sir. So I've marked Mr. Frankly Kritik Roshan has asked about suborbital space tourism.
Yeah. Okay.
So
Yeah,
this
it is
question,
finally Blue Origin. Yeah, Blue Origin has been started already. And the ticket price, it's around two lakh. I mean, Indian rupees is like $250,000, something like. You can write to the Virgin Atlantic CEO, or maybe the commercial director. She can respond. So there will be like even we are also planning actually. I did not going to reveal right now, because in next 4 years we are planning, and we have the team. 10 people are working for the space tourism. We are planned to send 6 people to the stratosphere, and they will come back. They can experience like it is actually the plan was started in UAE. We have given an initiative, because the space tourism is like sending the couples to the spend the honeymoon or some kind of the some vacation in the space for a few hours, something like that. So that was the budget. The problem is like still we are finding the sourcing for the funding, and once it is get clearance, then we will start initially. But we already working on it, is in the progress, and we have taken interns from around 20 people around the globe, and people are working right now.
yes, sir. And Mr. Manisha Bhaskaran has asked, can you discuss about the help of satellite images in the field of surveying?
Yeah, the this is what the next thing actually, the field of surviving. That's why in UAV and in Abu Dhabi and all, they have they have the digital copy of your home itself. You can see what how many rooms you have, how many kitchen rooms you have, how many bedrooms you have, how many lamps inside. It is everything has been digitalized and documented actually. So, and also the properties. For example, in Russia, they have, what they do use the satellite technologies, because they one single person they can own more than 5,000 acres of the land, hectares, few thousands of hectares of the lands, because Russia is the very biggest country, and the people have everything is like a digital copy of the documents. And some of the private companies are in Russia. They do the surveillance. They use the drones, and they will capture the entire your property, and they load it into the in your computer, and you can see you can give to the government, something like. So the surveillance, it is happening. There are many actually, for even for example, before the someone is taking the action. For example, a granite hill, you are taking some tender, and you want to acquire something like that. They go and estimate actually. So for example, if you want, I mean, you can able to estimate the water, how much how many liters of the water in the lake, something like that. So they have, and also they use the drones drones and also satellite images to identify the diamonds mines actually. Especially in ISRO also successfully I mean, demonstrated using the satellite. They can able to identify how much gold is there, how much titanium is there, how much alloys are there. You can find ISRO has been identified some mineralogical mapping they have done. They identified these are the spots you can able to find the diamonds there. This is the diamond tunnels there. You can extract there. So these are all used in mostly used in Africa, especially in Kenya, and mostly in the Ghana, those places. They're spending a lot of money for this purpose. Actually, the satellite images, they want to identify the right location, and some people they use for to identify the water tunnels in. So this cases also they can do on it.
Yes, sir. So, what will be the future for the aerospace engineer?
There is a, I mean, the future for
And another participant has asked, like, whether after finishing B mechanical, whether they can do master's degree in aerospace.
actually I done bachelor's in mechanical, and then I joined in MIT in Chennai in aerospace engineering. So even Shivan sir, I mean, there are many people are there actually, like, but it is not, the aerospace is not mean for only one actually. So the aerospace it means for everybody. It's like that's what I shown in the my presentation also. Uh, the artificial intelligence comes in every place, in the smart manufacturing, additive manufacturing, mechanical engineers. The software peoples are coming in IoT, and hardware electronics people are coming there. There is no nothing. There is nothing to do with a degree or something like that. That's how the technology is now. Anybody can work in ISRO, or anybody can work in aerospace industry. You can IT, or you have some separate roles to do actually.
Yes, sir. And Ms. Anindya Narayan Singh has asked, like, to which extent the privatization of the aviation sector will help the government to regulate it. So,
Uh,
what would be the disadvantages?
the only the thing is like the cost of the price tickets, and they will, like, in the beginning stages, some of the companies have been started the metro actually in Delhi, in New Delhi. They charged 160 rupees approximately. I mean, you are going to the airport. But if you go in a normal bus, it will take 5 rupees or 10 rupees. If you go then the taxi, it is 100 rupees, not more than that. But sometimes the privatization is close to the super expensive. Even a COVID situation, the private hospitals they can charge. The government set some standards, like some set limitations. Like for this much distance, you need to travel. This many air miles you need to travel. So it means we have to set the price actually. So that regulatory must be done, and then the privatization is always the good in airlines industry, because they are very very fast. I mean, some of you guys have been traveled in in Indigo, and in Air India, and maybe the different airlines, you can experience something really different. The way you treat in Air India, that is something is different. The way the people treat in Indigo, or fly Emirates or something, like different airlines. So even a trains also privatization is coming, and they are going to give some, I don't know, like it's 30 years contract, or I don't know. It's like recently the Home Secretary has been mentioned about this thing. So there was sometimes there are positives and negative. I mean, something negatives are there, pros and cons, but anyway, we have, for example, if privatization comes, means the employability is create more actually, more employability, many people, and they have the agility, like, in the government, you can, once you get employed, then you can, until you die, so until you get retirement, there is, you will work. But in the private sector, there will be like some kind of the fear, and also you can have a lot of remuneration, and you can earn money in 10 years, like the work you do in the government, something like that.
Yes, sir. So we'll take up two more questions, sir. And
Yeah.
to what extent we lack in technology to develop our own fifth generation fighter craft?
Technological, this is, there are major challenges are, okay, so I mean, we can design anything. Okay, the thing is we can design anything, but you need to produce it, make it happen actually. Like you have a dream, and you start building, for example, you are dreaming something, to build your aircraft, and once you want to make the realization, that will take the years to come up. So similar way, it's like the technological, to understanding the technological things, and also manufacturing abilities, that we have to see. And nobody will give the, for example, and especially in the fifth generation, I mean, electronic warfare, and also the who nobody is exchange the documents actually. Especially I was in with the military, India Russia military cooperations. It is, and even last November we have a meeting. Amit Shah, sorry, Rajnath Singh ji, Minister of Defense, they came to Russia, and we have a wonderful discussion and developing the next generation. I mean, military cooperations. There are several things have been discussed, but in on reality, we have to see. It will take to understand the system. It will takes 1 or 2 years minimum of maybe 500 engineers and scientists, and then next it will goes to the next step. They think, and the hardware upgrades, and also the technological advancement, materials advancement. There are many things are coming up actually. So you have to plan next. What will you see in 2030? How your aircraft look like? You start working today, then you can realize in 2030. So if you work for today, like today is IoT people talking about artificial intelligence, they are not nothing new. You can see in 10 years back itself, they have predicted artificial intelligence and cognitive sciences and these things actually. So you need to work for future actually, not for today technology. What we do is people will say, okay, everybody is studying artificial intelligence. Find any institute or anybody online course, just Google it, find it, and study and get certificate. And this will not help them to for the current generation. They have to work for the future and also to understand to upgrade the skills is constantly. Then only they can realization can be done. Even DRDO also Make in India initiatives have been happening. You cannot make the complete aircraft actually. For I'm saying my advice is like for the component manufacturers or something, you can identify one critical component or critical technologies, then you can pitch it, and then it will be you can able to get the contract in DRDO or government, and you can help them to grow actually. If you think you cannot make entire aircraft or entire system on your own, like automotive industries, for example, if you think.
Yes, sir. And regarding this, one more question, like, is any industries offering internship related to this aerospace? Whether ISRO is offering an internship program for college students?
Yeah, there are very minimal, and you can write to the public relationship officers, and you can approach them, and there will be like several divisions actually. For example, ISRO having the several divisions like VSSC, Sahar, and satellite applications. Centers. So there are many thing actually. So you can approach. You can don't look at that ISRO. Don't go to www.isro.gov.in. You cannot find any internship there actually. That is the headquarters handling everything on business. So you have to look center specific. For example, Sahar, VSEC, or LPSC, Liquid Propulsion System. There are so many divisions. Satellite Application Center is constantly recruiting the people. Actually, every year there are even people are working on final year projects for projects, and also master's project. And some people are working on respond program like academy industry research programs and all. So you can look into the every. The subdivisions of ISRO organization, you can find and offer. And we do the right now in the COVID-19 situation, pandemic situation, we offer the virtual internship. We have received around 20 people right now, and currently they are working with us on that is the space tourism project. That is like we are building the one balloon like the capsule that will fly to the space and come back like that. So we and some of them from UK students, some of them are from Indian students, some of the IT folks are joined as like virtual internship. Right now is going on. And if you are interested to internship, you can feel free to write us. So we will look forward.
Sure. Thank you, sir, and thank you for spending a valuable time for us and giving us knowledge about the aerospace engineering and aviation technology. Thank you very much, sir.
Yeah, thanks a lot.
Happy to connect with you in the future, sir. Thank you.
Yeah, thanks a lot. Thanks for a day.
Thank you all the participants.